So this is a table of all the common Taylor series. So if you look at this, so for example, if you look at this, if you differentiate natural log 1 plus x, you would get 1 over 1 plus x. So if you differentiate this, you would get this, which is this thing here. So what that means is, if you differentiate this whole thing, if you differentiate this, that will then give you 1. Differentiate this, that will then give you this. Differentiate this, that will then give you this, and so on. So all these are all the common Taylor series. But suppose you want to find the integral of this. You want to find the integral of sine x squared. So imagine this as this. So make use of this. So imagine this as being x squared. So put the x squared into here. So that will be x squared, and then put the x squared into here. So that will be x squared to the power of 3 over 3 factorial, and put the x squared into this thing here. That will be this thing to the power of 5 and so on. So tidy this up. So this becomes this becomes this, and this becomes this, and so on. Now it's easy to integrate. So this is your sine squared. So if you want to integrate it, then integrate each individual part. So integrate this, that will then give you this. Integrate this, that will then give you this. Integrate this, that will then give you this, and so on. And then you've got your constant. Okay, so you can make use of that table to do a lot of useful things. So this is your common. This is a table for the common Taylor series. So suppose you're given something like this, one block multiplying another block. So you can make use of this table. So your e to the power of x. So that's this one here. So it would be this whole thing here, multiply with cos, with this thing here. So simply get this whole series here. Just get this whole series here. That will be this, and then multiply it with this whole block here. So that will be this block here. So if you multiply this out, so this times this would then give you this. 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 This times this would then give you this, and so on. And then the next part would be this times this. That will then give you this. This times this. That will then give you this. This times this. That will then give you this. Don't forget the minus here is taken out here. So this times this. That will then give you this, and so on. And then this times this, that will then give you this. This times this, that will then give you this. This times this, that will then give you this, and so on. So now tidy this up. So here you've got your 1. Here you don't have a constant. You don't have a constant, so it remains the same. X to the power of 1. You don't have x to the power of 1. You don't have x to the power of 1, so it stays the same. And then to x squared. So now let's look at x squared. Hang on. Let's look at x squared here. X squared here, you've got an x squared here. Over here you don't have an x squared. Over here you don't have an x squared. Over here you don't have an x squared. So it's just a matter of simplifying these two. So these two will cancel each other out. So there will be no x squared here. Okay? And then x to the power of 3. So x to the power of 3, x to the power of 3. You don't have x to the power of 3 here. So now it's simply this and this. So let's times top and bottom here by 3, just to get the two denominators to be the same. So this will be x to the power of 3 over 3 factorial, times, for this one, times top and bottom by 3. That will then give you 3x to the power of 3 over 3 times 2 factorial. Same denominator, so we can now take away. So that will then give us negative 2x squared over over 3 times 2 times 1. So these two cancel out, giving you x squared, x to the power 3, sorry. Now, this take away this will then give you minus 2x to the power of 3. Okay, and then these two will cancel out, giving you minus x to the power 3 minus x to the power 3 over 3 over 3. Yeah, so clean this up. That will then give you this. Now x to the power 4. So you've got x to the power 4. You've got x to the power 4, and you've got x to the power 4. So merge these together. So same denominator, same denominator. So let's just merge these two together first. That would be 2x to the power 4 over 4 factorial. And then we've got to take away this. So that would be minus x to the power 4 over 2 factorial, 2 factorial. Get the two denominators to be the same. So let's just imagine this as being 4 times 3 times 2 factorial. So now just times top and bottom here by 4 times 3, 4 times 3, times top and bottom here by 2 factorial. 2 factorial, well, times it by 2. So this whole thing here will then become 4x to the power 4, and then you take away this thing here will become 12x to the power 4 over 4 factorial, 2 factorial. Okay, so this whole thing here will become negative 8x to the power 4 over hang on, let me think, over 4 times 3 times 2, and then that's 4 factorial times 2 factorial. So this 8 here, this will cancel out with this, leaving you with 6 at the bottom. So it would be minus x to the power 4, and then you've got your 6 at the bottom, and so on. If you have time, or well, if you continue, you can take it all the way to infinity if you want. But the point is that if you get given the combination of the two, then you can just make use of the table and just multiply the series together. So here we've multiplied this series with this series, and so on. Okay.